In this third question, the diagram shows 2 points A and B on a circle with center G, drawn for you already. The equation of the tangent to the circle at the point 1, negative 12, please note that the number here should be negative 12, all right, is x plus 5y plus 59. So let's write this in case we missed it. This is x plus 5y plus 59 equals to 0. All right, show that the coordinates of G is 2, negative 7. The coordinates of G is 2, negative 7, and G is here, proposed to be center. All right, G is proposed to be the center. How can we prove that the center is indeed 2, negative 7? Now, the center is stuck to the radius in that sense, all right? And the radius, there's one dotted line radius drawn for you to the tangent. So if I may, I perhaps can find out what is this one here. All right, if I have the equation of this line here, and then if I find another equation, I solve it simultaneously, I can actually find the point G. Another equation come from where? Our properties of perpendicular bisector of chord can come to place. Now I have this one here. All right, I have my AB is a chord. In fact, if you look at the value, all right, you look at the coordinates of your A, all right, and the coordinates of your B, all right, you will see something unique. This one, negative 6. This one, negative 6. So if I were to draw, all right, if I have to, I can actually draw my x-axis in. It will look something like this one here. If I were to draw in my x-axis, I might get something like this. All right. This is my x, this is my y. But is it necessary to draw? No, because we know one thing for sure is that the negative 6 here and the negative 6 here shows that this essentially is a horizontal line. All right, this is a horizontal line parallel to the x-axis. Okay, so if I have this information there, I know that if I draw a perpendicular bisector, if I draw a perpendicular bisector from the center G, this and this is the same. All right, and we know that there is a midpoint here, midpoint of AB. So if I can find the equation of this blue line, and I can find the equation of this light blue line, the intersection point will be the G. So let's go find the equation of the dark blue line first. Okay, so midpoint is what we have, because to find equation on line, we need a point as well as the gradient. So let's go find midpoint of AB. In fact, you don't have to find, you can see a 7 and a 3 quite expectedly. The midpoint of AB, you will get negative 3 plus 7 divided by 2 and negative 6 minus 6 divided by 2. So that will give you 2, negative 6. That's your midpoint, 2, negative 6. Now, issue is gradient. Just now we discussed that the AB is actually a horizontal line. All right, what's the gradient of horizontal line? Gradient of horizontal line AB in this case. We know that there is no change in y because the change in y is 0, so the gradient is actually 0. Then what is the gradient of the perpendicular line then? Gradient of perpendicular line. Wow, Mrs. Chow, you mentioned gradient of perpendicular line, you can use negative 1 over gradient of the AB in this case. Then in this case, isn't it negative 1 over 0? Can a gradient be negative 1 divided by 0? The answer is no. But one thing we know is that the gradient, therefore, of this blue line here, or rather the equation of this blue line here, all right, the equation of this blue line, if this is a horizontal line, we know that this one, all right, if this is a horizontal line, then we know that this one, since it is perpendicular, has to be a vertical line. All right, what's the equation of vertical line? Equation of vertical line is always x equals to something. All right, and in this case, because the vertical line passes through the M, we therefore know that the equation of that perpendicular bisector, all right, the equation of the perpendicular bisector is actually, let me write that down, equation of perpendicular bisector is as good as x equals to 2. Can understand why? Because of this coordinate here. Okay, any point on this vertical line will be 2. Okay, so equation of perpendicular bisector is 1. And now the problem is how to find the equation of this dotted line then. Equation of this dotted line. To find equation of a line, we need a point and a gradient. We need a point and a gradient. How to find the gradient? We know that given this line here, x plus 5y plus 59 is equal to 0. The gradient of the tangent, rather. All right, so we know that 5y is equal to negative x minus 59. Y is negative 1 over 5x minus 59 over 5. We know that this is the equation of the tangent. So therefore, gradient of tangent is actually negative 1 over 5. So to find the gradient of this purple line, here, all right, we therefore know that this is the, since they are perpendicular, so gradient of the radius as shown in diagram, all right, will be negative 1 over negative 1/5. So that gives you 5. And there is the point 1, negative 12 that passes through the purple line because it sits on both the tangent as well as the purple line. All right, then we will know that equation of GQ, as what the question calls it, equation of GQ is y minus positive 12. Y minus negative 12. So that gives you positive 12 equals to 5x minus 1. So that's y, 5x minus 5 minus 12, so minus 17. So we have found the purple line, that's equation 2. We have earlier found the blue line, which is equation 1. So therefore, we know that sub 1 into 2, we will get y equals to 5 times 2 minus 17. That will give you 10, negative 7. I'll give you negative 7. All right, so therefore, center of circle is 2, negative 7 shown. All right, so what you did was to go find center of circle, you're trying to use two simultaneous equations to solve a pair of simultaneous equations to solve them. All right, to find the two equation is the critical. To find the two equations, whenever we want to find equation on line, you must always have gradient and at least 1 point. Gradient and at least 1 point. So you go and find the gradient and at least 1 point of the blue line. Then you go find the gradient and at least 1 point of the purple line to form equations 1 and equation 2 to get the center of circle when you solve simultaneously. All right, then part 2, not difficult at all. All right, part 2 wants you to find the equation of the circle. Now that you have center of circle, to find equation of circle. To find equation of circle, you need center, you need radius. We have center, so now it is radius. All right, radius of the circle, we take the center of the circle, and then we extend it to one of the points. So let's try Q, because Q is given, or A or B, all are okay. All these points are given to you, so as far as possible, use them. So I can have a 2 minus 1 square plus 7, or rather negative 7. Negative 7 minus negative 12 to give me 12 plus 12. So that gives me a radius of square root 26. So therefore, equation of circle is x minus 2 square plus y minus negative 7 square equals to square root 26 square. So that's x minus 2 square plus y plus 7 square equals to 26. There you go. Equation of circle. So again, I mentioned we start off with a diagram. If the diagram is not given to you, let's sketch it out. If a diagram is given to you in this case, you can actually use the values and plot it in to have a visual sense of it. Bearing in mind, always note that where are the points on the circumference? Where is the circle? Is there an existence of a midpoint? Is there existence of lines? That's where you can start to solve.